You're watching Analog Output. I'm Rich Holmes, and this time I'm building the horstronic Buffmult module. Now, this is a buffered multiple, which I bought in the hopes that it would fix the problem I'd encountered with the Mother 32 keyboard control voltage. And as you'll see, it didn't, or not in the way that I hoped, but it did after I resorted to cheating a little bit. Now, this is not the least expensive buffered multiple on the market, but I think it's probably the least expensive that has buffered outputs as well as buffered inputs, and that has trimmers on the outputs that allow you to calibrate the gain. And these are probably not crucial features most of the time, but I wanted them anyway. And one of those features, as it turns out, was important. You'll see. I got the kit last month, and after I built the attenuator and the mixer modules, I opened it up and took a look at it, and I got a surprise. And here we have the third and last module from the box. This is a horstronic buffered multiple. And let's see. A bunch of little bags. That one's trimmer potentiometers. This one is SMD resistors, which surprises me because it says on here through-hole kit. I wonder if I've got the wrong thing here. And a couple more capacitors. But yeah, the resistors are SMD, and that is not what I was expecting. Okay, let's try this again. From DigiKey, a 14-pin IC socket, or two of them. Header for the Eurorack power connector. Bicolor LEDs, 8-pin IC socket, 6.1 microfarad ceramic capacitors, 2 Schottky diodes, 1 TLO72 op amp, 6 47k ohm resistors. Here's 6 300 ohm resistors. And the resistors that I got were the mini size ones, which I don't know, I dithered about that a little bit, but thought they might fit on the board a little better. Also, some of the resistors I wanted, they had the most conveniently in the mini size. And they're spec'd about the same, except that they have a smaller maximum voltage, like, 350 volts instead of 500 or something like that. And they run hotter. So I think they'll be fine. These are larger resistors, 13.3k ohm. We have a couple of 4.7k resistors. We have a couple of capacitors here, 6 picofarads. A couple more resistors here, 220 ohm. These are the 2 TLO47 op amp integrated circuits. These are the 2 electrolytic capacitors, 22 microfarads, 10 puff capacitors. Only need 6 of them. 6 43k ohm resistors, 4 100k ohm resistors. That's it from DigiKey. From a seller on eBay, 6 trimmer potentiometers, and from SynthCube, we've got 8 jacks, power cable, front panel, and printed circuit board. Here's the story. The horstronic Buffmult was released originally in 2014. That original version was designed for through-hole components. In 2017, the module was revised with a completely new circuit board layout. And in this version, there are holes drilled for through-hole components, but the resistor and ceramic capacitor pads are close enough together that you can use surface mount components instead if you choose. This is why I did not start with the resistors when building this, by the way, because with the close hole spacing, the through-hole resistors all have to be mounted vertically. There isn't room for them to lie down horizontally, so they're not the lowest components. Anyway, Horstronic produces just the boards and the front panels. The full kits are put together by SynthCube, and despite what it said on the bag label, they chose to supply surface mount resistors with the kits and through-hole capacitors for whatever reason. But they don't mention surface mount components in their listing for this kit, and to my discredit, I didn't even think about it. I just implicitly assumed the components would be through-hole, so I got a surprise. I probably would have returned the kit solely for that reason, but on closer examination, I found another problem. My kit was missing several of the components, so I definitely did return the kit for a refund. I did want to build this module though, so I ordered the board and panel, as well as the jacks and the power cable from SynthCube, and as you saw, I got the rest of the parts from DigiKey, except for the trimmer pots. There are 6 of these trimmer pots, and at the price DigiKey was charging, they would have been about half the total cost of the order. Instead, I found a vendor on eBay whose price was so much lower it still saved money even though I had to pay separate shipping. So that was how I ended up building a module not from a full kit for the first time. And there was another first. I built this module without consulting the build guide, for the simple reason that there isn't one. You're supposed to be able to figure it out on your own based on the circuit board silkscreen and the schematic and the build materials, which are available online. So, was I able to? I was, based on experience with the first 4 modules I built, and it's a pretty straightforward circuit. One PC board, not that many components, nothing especially weird going on, so I didn't have any trouble. Okay, so we've got the module here. We've got a low frequency oscillator plugged into it, and if I turn on the power, we see the LEDs. I hope this shows up in the video, but the LEDs are blinking red, green, red, green, red, green, red, green, indicating that, yeah, we've got signals going in. And if I move this thing down to the second input, then we just have the second LED going red, green, red, green. So the first section is normal to the second section. Okay, and I haven't done anything beyond this, haven't checked the outputs yet, so let's see if we get some reasonable outputs. Okay, now if we take this LFO and if we run it into VCO mod, there we got that. All right, now if we take this and put it into one of the inputs and take one of the outputs into VCO mod, okay, that's working. That's working. That's working. Okay, so there's the good news. We get outputs. And now it's a question of, can we calibrate this to volt per octave, well, to unity gain, and can we get volts per octave behavior by using the buffered multiple, which was the whole point of getting this thing in the first place. That's going to need a little more work. attempting a calibration now based upon discussion online. What I've got is I've got a voltage going in here. It's actually the output of the Mother 32 VC mixer with nothing going into it. So if I have the knob turned all the way to the left, it's 0 volts. If I have it turned all the way to the right, it's about 5 volts. And this thing is connected to one lead of my multimeter here. The other lead I've got here. And if I put this on one of these outputs, it's showing a small, let me turn down the scale here. It's showing a 23 millivolt difference. This is measuring the difference between the input voltage and the output voltage, and it's 23 millivolts. So now I'm going to take this and turn it down to 0 millivolts. Okay, so now it's 0, and that's with 5 volts in. If I make it 0 volts in, it's reading an 8 millivolt difference, 8 or 9 millivolts. If I turn up the voltage, and we got a big difference, we got 78 millivolts here. So I'll turn this back this way. Okay, here we get almost no change in the difference, the output. There is a 9 millivolt offset between the input and the output, but that's not changing as we change the voltage. So that should be that's essentially a 0 gain, because when we change the voltage from 0 to 5 volts here, there's a little offset, but the change in voltage in the input is equal to the change in voltage of the output. I think that's what we want. Okay, so I'm going to try to do the other channels like that and see how it goes. Okay, well, we have bad news and moderately good news. The bad news is this. Let's take a look at this. This is the keyboard control voltage from the Mother 32. All right, so I'm just going to look at that voltage output, and at 3 octaves below middle C, it's reading -3. At 3 octaves above middle C, it's reading, well, it's reading 2.98. It was reading -2.99 before, so it's not perfect, but it's that's how close it is. This is, if you just take that output there. Now, if you take this output and plug it into the buffered multiple, and you look at that same thing, we'll just go from ground to here. That's 2.96. And if I go 3 octaves below middle C on my keyboard and measure it again, it's -2.96. So the problem I had before remains. The keyboard control voltage goes out of calibration when we plug it into a Eurorack module. That's the bad news. The good news is, it's sort of good news, is that since this buffered multiple is designed with trimmers to allow you to calibrate it, that means you can miscalibrate it. That means you can set one or more outputs to be a slightly higher than unity gain. Measuring from ground to input tip, we've got 2.96. ground to output tip got 3.01 because I have changed the calibration. If I go to 3 octaves below middle C, I've got minus 3.00. Okay, if I look at one of the other outputs, it's still measuring 2.96 on the other outputs. But on this output, it's measuring 3.0 because I've changed the calibration on that one. So the idea is this is a unity gain buffered multiple except for that one output, which has a slightly higher than unity gain, which is supposed to compensate for the problem with the keyboard control voltage. It's a kludge, but it should work. Okay, what I've got set up now here is I've got the unity gain output, the one that I didn't miscalibrate, or one of the ones that I didn't, going into the Buffmult even VCO. We've got the keyboard. I've hit here is a C, and on my tuner it says that this is dead on. I've got this tuned exactly to C. If I go 2 octaves up, it's telling me that I'm flat by about 34 cents. And if I go 2 octaves down, it tells me I'm sharp by a similar amount. Now, if I plug in the output of the miscalibrated output, it's again on middle C, it's exactly where it should be. If I go up 2 octaves, it's telling me I'm flat by about 5 cents. I'm going down 2 octaves. It's telling me I'm again flat by about 3 cents, 2 cents. Back to C. Well, now it's saying that's a little flat. Okay. May not be quite warmed up enough. But anyway, it's saying that the tuning is, as I go up and down octaves, it's staying in tune within a couple of cents. So, by abusing the calibration on the buffered multiple, we can fix the keyboard tracking problem. Ta-da! There we are. And I have learned a lesson. Never assume anything about whether a kit uses surface mount components. By the way, it's not that I never intend to do any surface mount work. I probably will decide to try it sooner or later. I just didn't want to try it right now on this particular module. The horstronic Buffmult. It's an easy build, even without a build guide, and it does the job. I recommend it, and especially if you have a Mother 32 with a problematic keyboard control voltage output. The Buffmult isn't designed to solve that problem, but you can coerce it into fixing it. And I hope you enjoyed this video. Please hit like if you did, and subscribe if you want to see more. I plan on building a VCA pretty soon, and I'm thinking about putting together a breath controller, which should be interesting. So stay tuned, and I'll see you next time on Analog Output.